Hey everybody! So in this session what we're going to do is we're going to talk about promises, async await and callbacks in JavaScript. Now over the years programming styles around using these different syntactic constructs has changed significantly as the JavaScript language has evolved, and I find when people are working with code of different ages, and certainly people that have learnt just from observing other code that's written in the language, the understanding of what callbacks are, what promises are, and how promises led to async and await is quite vague, and often people produce some really bizarre code that dances around their lack of understanding of promises. So I want to do a bit of a deep dive into where all this stuff came from, what problems that promises and async and await were trying to solve, and how you can use them better in your code base. Now we're going to demo this stuff using Quokka PRO, which is a scratchpad that runs inside of Visual Studio Code and a bunch of other IDEs. Now this isn't a sponsored slot or anything, I just absolutely love this tool, and I'm going to show you how it works now so you understand where these demos are going. So it's very simple, it's an untitled file in Visual Studio Code, and if I type console log here, you can see that the console output is inlined into my IDE, and also you can see if I make subsequent calls here that the output is revealed in the output window on the right hand side of the screen. So as we work through this demo, I want you to pay attention to both halves of the screen. Okay, first let's talk about callbacks. Now callbacks are really simple to understand. They're just a function that is called at some other point in the future. There's nothing special about them, they're just functions. So if I was going to type a function here, my function, that started out by just logging hello world, and I then invoked it, you can see in the output we have hello world displayed. Now if I wanted something to happen after I'd logged hello world, my function could take a callback. Now because there's nothing special about callbacks, in order for my callback to actually be used, I have to write some code to invoke it. Then you can see my code is now throwing an error because the callback is not a function. I haven't passed anything. So we can of course provide an anonymous function here that says goodbye world, and the output will then, as you can see, read hello and goodbye world. Now you don't have to use anonymous functions to make this work, so if I delete this now, you see we return to our error state. I can create a function called nextThing, which says I am the next thing. Now I can just pass that function to my first function, and the same code works because in JavaScript named functions and anonymous functions are interchangeable. Now why would I want to do this? Well, obviously these functions are quite synthetic and aren't really doing very much, but what you might find is maybe my function goes off to some API and get some data. And when that API call finishes, what I actually want to do is interact with that data. Now because of that, I can just put data as a parameter here, and if you watch, if I add that to the console log, you can see how I can then capture some data from some operation and act on it later. Now this is a really common thing when you're calling APIs using XHR requests in JavaScript, using AJAX calls, and a whole bunch of other JavaScript libraries use callbacks to give you hooks to add behavior onto other things that are happening in a library or a framework. Like, this is a really very common pattern, and for the first 10-15 years of JavaScript it was the only pattern that we had. Now this is, I suppose, a side effect of the fact that JavaScript is single-threaded, mostly. We're not going to go into details around that, but mostly single-threaded, which means that anything that you want to do later had to be passed down as data. Your function had to be passed as data through your application, so at the correct point the code that finishes preparing the data or doing an operation for you can invoke that callback and let you return control back to somewhere else in your application where your function was defined. The most obvious place where people may have encountered callback functions, and the place that might make it easier to understand, is when you look at setTimeout and setInterval. Now these are two standard functions that are built into the language, and setTimeout takes a function, so I'll provide an anonymous function here, and what it does is it will call this function after the milliseconds provided, so after a second this said hi. Now setInterval makes this easier to see, because if I call setInterval, you can see hi starts repeatedly printing in my output log every second. Now this is a callback. setInterval does some message queuing things in the JavaScript runtime, kind of depends on the implementation of your runtime, and is a really obvious place where you'll see callbacks happening again and again and again. But here's where things get interesting. Let's imagine my setInterval function is going to make a web request. And I'm going to do this web request every second, and I want to operate on the data. Now, what I'll probably end up with is something like fake browser fetch. So we're going to type a function here that's going to pretend that it's a browser fetch, and this is just going to return some data. And we're going to call it response. And this thing here takes time. Now, we're going to pass do web requests to our setInterval, but actually now, once we do our browser fetch, we want to do some behavior, some operation, and what we'll find is this function wouldn't just return the data; it would do some hard work, and it would require a callback. So we're going to store the response, and then we're going to call our callback with a response. Now, in order for this function to work, my do web request function would probably want to say something like URL equals temp URI some API, and then it's going to do a fake browser fetch, but then obviously I have to inline this callback, and all of a sudden the code is starting to get difficult to read, because what's really happening here is setInterval is calling do web request, which is forming a URL and passing an anonymous callback function to here to console log my response that's being triggered from this line of code here on line 13. Now this is really synthetic, right? Because in a real application you wouldn't just want to console log. Maybe you want to store data in database is perhaps what you'd want to do. Now then, what we'd end up having to do is realize that to get this function call in here, well, perhaps I could put it here, and that would be okay. But maybe store data in database had a separate set of callbacks of its own, which perhaps there's a callback on save, callback on error that you need to provide here. And all of a sudden, you end up getting all these callbacks and passing them through big chains of function definitions, and it's really difficult to visualize the flow of data in your application. Now this lack of linear flow in programs is really problematic if you're trying to debug things and trying to work out where any piece of code is executed and what triggers it. So what we're going to do is we're going to rewrite this example, and we're going to use promises. So what we're going to do in this next segment is we're going to see how promises can help us improve this really kind of confusing non-linear flow of control in our application. Now the problematic bit of code we're looking at specifically is this fetch function. Now do web request is fine. This will be run here every 1 second, and we don't have a problem with this. But because fetch takes a function, and because that function then triggers store data in database, which takes 2 subsequent functions, this, you can see the pyramid forming here, and we need to use a promise to make this make sense to the reader. Okay, so now using this very concocted example of a fake web request that saves some data in a database, what we're going to do is we're going to see how we can use promises to add syntactic sugar to make the flow of control in this program more obvious and more linear. Now, a promise represents an asynchronous operation that hasn't yet completed and can be in one of three states. It can be fulfilled, it can be pending, or it can be rejected. We're going to add promises to the store data and database function in our example code here to make code that uses it a little bit more obvious and a little bit easier to read. Now you use a promise by newing one up, and a promise takes a resolve and a reject callback. Now the idea is that you call those two functions when the downstream asynchronous operation has either completed or failed. So we're going to take our logic here where it says callback on save, and instead of doing callback on save, we're going to take this and we're going to resolve our saved data. Now we can delete this callback, and we can also delete our callback on error. Now, if an error had occurred, we call reject error details here. Now we have this promise. What we do is we return the promise from our function straight away. We can change our calling code to interact with it. So we can call store data and database, and then we can use the function then provided on that promise to interact with the data that's resolved by our code. So you notice here, I can take this console log that was in this nested callback here, and I can add it here. And I can add a catch block to represent the error handling case. And what we've done is we've made our code read a little bit more linearly. So one of the things we could do now we have our callback code converted to promises is we can introduce functions that describe the steps, log result for instance. And we could take this piece of logic here and we could paste it there. Now we take this function here, and instead of having everything inlined as an anonymous function, we can kind of set a chain of operations up here, handle errors. And this here would say an error has occurred. And you see how we can make our code read a lot more obviously by building these little chains of then and catch. And you know what? The cool thing is you can repeatedly use them blocks to deal with the output of previous steps. So that's one way that promises help us, but really promises were just part of the journey towards using async await for these asynchronous operations. Once promises made their way into the language, it wasn't a big leap to take some of the async and await syntax that was evolving in other languages like C# and apply it to JavaScript. Now, I believe some of the language designers or the people that hashed out these specs were the same people that worked in other languages that have done a similar thing. And what we're going to do is we're going to take a look at converting our promise-based code with method chaining of then and catch into using the modern syntactic sugar of async and await to capture the asynchronous flow in a linear way. The first thing you have to know about async and await in JavaScript is to use the await keyword to await a promise. You have to already be in an asynchronous function. So what we're going to do here is we're going to convert our anonymous function here into an asynchronous function where we can use the async and await keyword to resolve our promises rather than using the then and catch functions that are part of the promise API. So to make your function asynchronous in JavaScript, all you have to do is use the async keyword. And we can kind of break this down into its constituent parts so you can see what our promise, or you see what this looks like. So if I were to break this up, these calls look like this. You're going to see those three calls. And then and catch still work as they were before, we're just not chaining our functions together. But now that we're in an asynchronous scope, we can do this. We can say const value is await our promise, and then we can just call log result value. So we remove this then chain. And once we let this pick up, you'll see save data is now working again. And we can also we can add a console log here. I got value. Oops. And you will see that like our console log here works as well. I got value. Perfect. Now that takes away that kind of degree of indirection that using then leads to. Now in asynchronous code, handling errors is slightly different. So instead of using this catch function, what we should do is we should wrap our entire block of code in a try and catch statement. So our error handling will be done here. Now you can see that as we open up this code, it's kind of cleaner but still a little bit confusing. So let's trim out some of our extra console logs. You see how that's a little bit simpler to read. And the nice thing is we don't need to capture our promise into a variable. We can just combine these two lines. So all our code has to read is value is await store data in the database, and then this value is our actual object returned. There's nothing more to it. You don't have to chain anything. So now that we're using async and await in our anonymous function here, let's see if we can expand this to make our fake fetch function return a promise as well, to really make this do web request function super linear. Now obviously because our fetch function doesn't do very much at all / anything, what we really need to do is just return a new promise with resolve and reject, and then we're going to pick up this logic from our fake API call, and again instead of using a callback, all we're going to do is we're going to call resolve when we get our data from our API here. So now when we go up to the point where we use this code, what we're going to do is we're going to take this function, we're going to make it asynchronous. We're going to take our body code here, which was previously in our callback, and we're going to remove that from here. And then we know that fetch is now returning a promise. So what we can say is we can say const API result equals await fetch. And now this result here is the same as the response that we had here. And we can even put both pieces of code inside the same error handling block. And now our code looks so much more legible because there is no nesting, there's just a single error handling block, and you can read everything linearly. Now the really nice thing about the code now being a lot more linear is you don't need to declare as many named functions to do really trifling things, because you're no longer having to pass them around. So this code now makes much more sense to have its log line right here. And equally, the error handling line is much more suitable right here. So if I remove these two functions, I can make this a little bit prettier. So what you can see here is really what we've been able to do is reduce the total number of lines of code while enhancing clarity by using async await with promises over both the original callback piece of code and the code that required manually chaining thens and catches along our promises. Now the even nicer thing about this, because not only can named functions be asynchronous, but anonymous functions can be asynchronous, we could actually inline a lot of our program into a function in our setInterval here. So we could just add the asynchronous keyword to an anonymous function. We could pick up the body of our function here, and we could make this far smaller yet again. So I think what this does is it captures the intent of what we're trying to do. We're trying to get something from a URL and store it in a database without bogging us down with callbacks and syntactic backflipping. One of the most important things in programs is that every character that you type really means something, and actually being able to see your user code free from then catch chains is really, really good for the reader. It's really good for maintainability, and it's really good for understanding. Now here's the good news. Most modern APIs are now using async and await inside their own code. And what that means is you don't need to manually return promises and create promises yourself anymore, because the async and await keywords are generating those promises under the hood for you in most modern code. Now, of course, the real win of converting everything to async and await happens when library authors themselves take functions like fetch and store data in the database and convert them into asynchronous functions, in which they can use the syntactic sugar of async await, and you will never see promises manually again. Now, of course, they're still there. They're still in the runtime. They're still being generated, and your JavaScript engines are still passing on the functions to thens and catch statements. But what it does is it just makes the code so much cleaner, and you never really have to worry about manually interacting with promises again, unless you want to, say, race two different operations or make sure you resolve a whole batch of things at the same time. So that's kind of the journey from callback-based programming to promises to async and await in a nutshell. I hope this has been really, really helpful, and I really hope that you can go to your own code bases and convert them to async and await. This stuff works now in the browser. It's obviously supported in Babel and Vite and all the other transpilation solutions for JavaScript. It's built into TypeScript. It's just plain better. So please go use async await today.